Okay, so
Yes.
so actually, why we started this session, it's because I think most of you have realized if you search even for a geospatial something on LinkedIn, you'll tend to see there's geospatial data engineer, geospatial data scientist, geospatial whatever. They can it's kind of our role is integrating with the various data roles, but we tend to focus now on geo more, right? And then it's great to really learn the modern skills, which I think most of you are already doing, like integrating with programming, doing Python, doing some SQL, doing some R, doing some Java. It depends, but yeah, it depends with the thing that you're interested in. Is and all in all, if one wants to be whether an analyst, data scientist, or data engineer, we usually share some key skills like SQL and maybe Python. And also, if you want to be like a data scientist, it's usually also at times, depending on the size of the company, you might need to know some data engineering if it's a small company, and they believe that the data scientists can do some data engineering too. And this is why we're having this session. So initially we did a session about the overall data engineering 101 with Giant. And today now we are doing the solely the key fundamental aspects, right? Which is about building data pipelines, right? Getting the data from the source, doing the ETL and stuff. You'll see more from Jant. Is way more expert in this. He has more industry experience in this, and is now a lead data engineer. So I figure out it's still way great for him to be the one to give this kind of talk. And I really hope most of you will get better insight. And if you feel you haven't understood something, you'll always ask the questions at the end of the presentation and the demo, because we are doing it both theoretical and practical. We'll try to make it short within an hour. Let's see how we go from there. So right now I'll hand it over to the end.
Hey, Brian. Yeah, thanks, Brian, for the intro. And hello, everyone. Okay, Brian has given a short intro about me. Just to repeat, I work as a lead data engineer at Kafu here in Dubai. So, as part of this series that Brian mentioned, that why we are doing this, and so since all of you are in the area of geospatial engineering, someone is in geo-informatics, but somehow related to the geoscience. So, as part of that field, you might know that how much important data is, because you hardly can do anything without data, and data needs to be cleaned. So when we talk about the cleaning aspects, then the data processing comes into picture. And nowadays there are so many tools and technologies coming up with respect to processing big data, huge volumes of data, and then curating it, transforming it, and then presenting in such a way that it is usable and it will derive insights, and you can derive insights from it. So today's session is based on like how we can build data pipelines, and I'm using, like, we will go through like how to build data pipeline using Airflow tool. So if some of you may not know what Airflow is, it is a workflow management system which is widely, and it's open source, and it's widely used in the industry for building data pipelines. So we'll go through that particular pipeline, how to build it using Airflow on AWS. And uh, this, since it's just that I am more familiar with AWS and have expertise uh, building data pipelines, data architectures, data lakes, data warehouses on AWS cloud. So I've chosen that it would be good to show it to all of you how to do those things in a cloud environment. So to agenda for today will be, so you're able, Brian, you're able to see my screen, everyone?
Yeah, sure, definitely.
Yeah. Okay, cool. So the agenda for today is we'll go through some problem statement. So how I am structured this session is, so I took a problem statement. Usually what happens is, even if you go for like various interviews, right? Typical, if you're going for a geospatial data engineering interview, then usually most of the interview process, how it starts is, once you go with the interview, like with the HR call, introductory call. They will either ask you to do a hacker rank, or they may ask you to take a take home exam. And the take home exam usually utilizes of building a ETL pipeline. They will ask you to use some workflow management tool, build a ETL pipeline, build architecture, and share the code that you built for the entire pipeline. So I have structured in that way. I took a problem statement. Then we'll look at how the block diagram for the ETL pipeline will look like. Then we'll go through how it will look like the architecture using the components on AWS. Then at the end, we will see that what will be the output of that pipeline. And at the end, we'll go see the pipeline in action. That will I will show you a demo. I have done some basic setup on AWS, and we'll go through the demo, and that part will be pretty exciting. So yeah, let's move on to the next slide. Uh, so assume you are in a company wherein, like for example, Amazon. So Amazon has so many product information stored. Then they must be having a lot of sales information stored. So here I assume that sales data is stored on Athena. So Athena is AWS managed Presto. It is a query engine basically. So I assume, and usually the data is stored on S3 files. So S3 is the object store on AWS. And I assume that the data, sales data lies in a sales schema, and the name of the table is sales data. The second table is we have the product information, which is also stored on Athena. Uh, and it is stored in product schema as product date in product data table. And the third one is not a, it is a third party source. Usually in building pipelines, you will encounter that you have to integrate with various third party tools, and you need to fetch data, and then using that data, you need to do some transformations. So basically what I am assuming is, so now in sales data, I assume that there we have like currency information stored either in AED. AED is the UAE dirham, and SAR is Saudi Arabian currency. So I'm assuming that we have data being stored in these two currencies. But now when we are going to report it, what we want to do is we want to convert it to a one currency format. So I chose USD. So we will convert those AED and SAR to USD. So that's a basic transformation that we will do, and we will store the data at the end. And all this output will be we will store in the data warehouse. So we'll look at it where what the data warehouse we will use and how we will store the data. So the expectations, right? Usually as I was mentioning about the interview cycle. So usually this will be the kind of expectations from your ETL assignment. So like proper infrastructure, you have to depict a proper process. Then you have to take in the aspect of that. You have to fully load you have to have the initial load, that is the full load. And then after that, you need to incrementally load data so that your logic should be that much flexible that you can do a full load and then an incremental load of data into a target store. Then your process should have retry and alerting mechanism. So for example, if there are intermittent failures due to like network issues and things. So your code should be resilient to that and fault tolerance. And in those cases, we need retry mechanisms, and also we need alerting if the process has failed. Then usually this update and insert operations, we call this an upsert. Now, for example, in our case, like product information. So maybe product information for one of the product, maybe camera, its price got updated. So we want to make sure that we pick up. So these are the kind of updations that happens at the source. And we want to make sure that we pick up the recent information and not the stale information. And then based on that, we need to update and insert the record at the target. So that is called as an upsert operation. Then handling that, doing data quality checks, that is the most important aspect, and we will see that how we do the data quality checks. And basically I use a particular library, we will go through it to perform data quality checks. Then logging process, and then using a workflow management system, and then doing data transformation and reporting. So usually these are the kind of expectations that would have in most of the ETL assignments, and so it's good that we will look it in from the practical aspect here. So here, this is the let me just ETL block diagram. So what the block diagram, it depicts the flow, that what will be the flow of the pipeline that we are going to build. So we have information like we have sales data from sales table, we have data from product table, and we have currency converter API. So we have three sources of information, as you can see on the left hand side. And our data pipeline, we will punch in these three data sources to our processing data block. And after the data is processed, that means some kind of transformations, we will store the data into a particular staging area. That is a temporary storage. Staging area is just a temporary storage space wherein data is stored for intermittent period of time. So that process data goes there into a staging area, and S3 is the object store on AWS. So I have chosen that as our storage mechanism for storing intermediate files and stuff. So once the data lies there, it will be in a CSV format. We will perform all the data validation and quality checks, as you can see in the third block. So what data validation may be, for example, is the row count greater than one? So if a certain column needs to be only integers and it cannot be floats or anything, so that kind of data quality checks we will perform, handling duplicates and stuff. And after that data quality checks are being done, then we'll move on to loading that data into a target. So first the data will be loaded into a staging table. Staging table in the warehouse is Redshift. So I've chosen a Redshift data warehouse. It's quite popular and it's being used for big data processing. So that's the target of this data. And these and that table name is revenue. So what we are going to do is, based on this sales information, product information, and currency, we are going to generate a revenue table, and we will see that what are the will be the columns of the revenue table, and what information will get stored there. But as the name suggests, that we will calculate the revenue per product, that how much revenue we collected from each product, and that information will be stored into the Redshift. So first it will go into the revenue underscore staging table. And from that, we will perform a upsert operation, that is update and insert in case of the particular ID, like for example, any sales ID or something what's existing in the source table. And now some dimension, maybe, as I said, that uh, dimension with respect to maybe the quantity or something changed, and we need to update that. So all those operations will be performed in the final step. That's why we make it's a good design practice basically to load the data into a staging table, and then we will perform this update and insert operation, and we will load the data into the target. So this is a overall flow that will happen, and that's what we will see in action today. So in terms of, and now this is something technology agnostic. I mean, there is no involvement of technology here. So the next slide, we will explain in terms of what are the tools we will use to process all this information. So now here you can see this diagram. So the earlier diagram and this diagram is almost same, but now we have brought in the tools that we are going to use on AWS. So on the left hand side, it's fine. We have like data stored in Athena. We have a currency converter API. Those are the input data source. Then all the ETL operation we will do using Airflow. This icon that you see, it's an Airflow icon depicting that we will use that tool for like processing data, building a data pipeline. And the process data, as I said, it will go to a S3 bucket, some staging area, and then we will run another type of cleaning and transformation processes, and the final data will get loaded into a Redshift data warehouse. And at the end is something that is a presentation layer. Right, in this demo, I might not take you to I have not built any presentation layer, but we will see some visualized results using the inbuilt tools on AWS. But basically, that once you have the transform data set, so what the work remains is the present the results to insights. So that's also important. But in today's session, our most focus is on data processing, how to build a data pipeline and how to get that curated and transformed data set. And in case of, you can see in the diagram, in case of any failures that happens, so it should have a failure reporting mechanism. And basically nowadays, I mean, most companies have Slacks, and they what they do is any kind of failure that happens, they report to Slack channels. So this is infrastructure, uh, a diagram that including the components involved on AWS. And to like why we chose this particular components, let's see that what advantages does it gives us, and how reliable the pipeline will be when we use these components. So for example, the first technology or the tool that we use was Airflow. So basically, it is a workflow management system, and it's Python based, and it's built around the concept of graphs. So DAGs means is a directed acyclic graphs. So if you have gone through the data structure courses, you would know that what a directed acyclic graph is. So that tool is based on that concept, and everything is in the terms of nodes. So you have nodes in the pipelines which are doing some work. We will visually see it later on, so you will get a very good idea of it. Then what all things does Airflow as a tool offers, right? So it offers inbuilt retry mechanisms, error reporting mechanisms, logging mechanisms. So all these are out of the box built within the tool. So you don't have to do any extra work for having this functionality. That's why nowadays many companies they adopt but they have adopted this tool for building their data pipelines because of the functionality that it provides. Then it also has built-in capabilities for doing incremental loads. That is, so you only process a chunk of data every day and not the full data. I mean, first initially you have to do a full load, but after a day by day, you just are interested in an incremental load. So that tool has that built-in capability for doing in incremental loads. Then the last is the parallelism. So the Airflow backend, right? Either you can have a Celery executor, there is Kubernetes executors, like what is executing your task. So there are different executors, and those executors are responsible for giving you that parallelism. So you can, so most like many, like you can have a number of tasks running in parallel, doing their independent operations and producing their individual results. So with this, the time to process your data is reduced, and your performance increases. So second aspect is the AWS ECS. It's a good thing to have some kind of, so ECS is the Elastic Container Service. So if you have heard of Kubernetes, so it is along the same lines, but this is an AWS product, ECS. It is used for container orchestration. In today's demo, I have not set up it's on ECS. I have set up the Airflow on EC2 instance just for simplicity and for the demo purposes. But in production grade, right? So if you want to have a production grade Airflow, then either you will go with ECS or you might go with EKS or any other strategy. But nowadays it's usually between the two, and it has its own advantages, right? Because if in now you, as the data volume increases, so you will have maybe 10x growth, 15x growth suddenly, then your pipeline should be able to bear that load. So in that cases, this ECS and EKS, it comes in very handy because they offer automatic scaling, scale up, scale down, reliability, and high availability. So in case of like you can identify if my CPU, it can specify a condition, right? If my CPU can load, or the usage or memory usage is greater than 90%, then spin up another node and distribute the traffic. So that is what scaling means. So when the threshold is reached, so ECS will automatically go ahead and provision the required infrastructure, and your load will be distributed, and your work will be done, and it will automatically also scale down when the load is reduced. So that is the reason why this type of tools, they are very important, and it is a and it should be used as part of building production grade infrastructure. AWS S3, it's the simple storage service. That's why it's named as S3, and it is usually it is serving as a data lake for many companies. For example, the company which I'm working here also, S3 is a very vital component because it serves as the data lake. If you don't know the concept, it's a place where all your companies, uh, historical stuff and all the data from the various sources are being stored at one place. It serves as like a central storage. And that's why we name it as a data lake. And it can host both raw data, transform data. Then we have a variety of services. So AWS provides Athena. We also saw it before, to query over the data lake, to query over the data which is stored on S3 files. So we can use Athena, and Athena is nothing but is AWS managed Presto, and it can be used for doing a bunch of exploratory data analysis. And but it has much more use cases. It's a distributed tool. That means it follows the norms of distributed computing. So Athena is managed by AWS. So the parallelism and the on which node the queries run and everything is structured, and it's something handled by AWS itself. Even the scale up and scale down is that happens in background. You don't even come to know. That's it's very powerful, because otherwise you can also set up your own cluster, basically a Presto cluster, but then you will have to manage everything by yourself. Let it be its maintenance, let it be its scaling policies, then security, everything that comes into picture. So if you have like low resources and if you want to get things quickly, or build prototype or even production grade system, and this managed tools which are provided by AWS, they are pretty powerful and they should be utilized. And it's my like personal choice, like as and when required, it's good to use the managed tools. Then yeah, depending, it depends on various factors. Anyways, it can be arguable, but I've seen the difference. Like when you use the managed tool, there are a lot of things which are just offloaded to AWS, and you can be at a bit of ease and focus on other important things. So in terms of S3, it also offers durability, then high availability, like AWS offers like 99.99%. They promise that it will be available, and good security, like access controls, like for protecting your data. And the last component that is used is Redshift. So Redshift is a data warehouse. Here we will store the transformed data sets. And from this, so your data, like for your creating your dashboards and everything, you will create from the data which lies in Redshift. And which will answer your questions. You might have some particular use case in mind, and you can get the data from the Redshift, build some visualizations, and it will enable your decision making. And we will like data from S3. So the intermediate staging data will be S3, and from S3 we will get the data into Redshift. And in terms of performance, it's a BI tool. So it's built for BI workloads, like big data loads. And it also has like automatic scaling capabilities in terms of high when there is work, when there are a lot of queries that come in suddenly. So you can also have a mechanism wherein when some threshold is reached, it might spin up another Redshift node and cater to your work, and then scale down automatically. So in terms of output tables, right? So what will be the output of today's pipeline? So we will give in three data sources: sales data, product data, currency converter API. So the first table output will be the revenue table, and we will also see the input table schema. But this is I'm talking about the output table schema. So we'll store sales ID, sales date, product ID, what quantity, modified date and revenue that particular product and sales ID generated. And the revenue is nothing but it is a calculation, just quantity into product price. And that product price, we will see that how from where that product price will come and where the quantity information is stored. So basically they're in the source tables. So we'll have to join two tables and then calculate that stuff, and also get the, and we want to convert the price into USD. So we will have to fetch the USD equivalent from currency converter API and do that transformation. So we'll look at the input tables, then at that time it will become clearer. And the second will be a report table. So it's basically product analysis report table. So typical scenarios, you have month to month reports that are being generated. So here, what does this report mean is, I want to get to know that which of my products was sold continuously on particular days. For example, for example, I have a camera, right? A camera was sold continuously, maybe on 3rd April, 4th April, 5th April, 6th April, like for 5 consecutive days. Then for next 2 days, it was not sold. And again, there was a pattern where it was sold on 3 consecutive days. But out of that, the maximum that we call as streak, what was the maximum streak is that the camera was sold was for 5 days. I want to get that kind of information. That is, for every product, I want to know that what is the max streak for that particular product. So in that way, what questions it will answer is, I will know that which products the people are buying continuously, and then I will also come to know that which products are not being bought frequently, or which were never bought. So in those cases, I might want to, have some marketing campaigns for the products which are not sold. I might want to give discounts to the customers so that they are encouraged to buy such products, buy that product. So this is what, anyways, it's one of the use cases what Amazon would do when you go to the website. And so even if you view a particular product, they will come to know, and they might just send you particular discount on the product. Okay, buy this product, we might give you 10% discount. So these things happens when you visit their websites. Everything is being tracked, and they know exactly where did you click, at what time did you click, which product you viewed. All the things are being stored in the background, and that's how the data mining is in the background happens. And they send you personalized offers. So it's based on that kind of concept that this product analysis report table. So now let's get to the exciting thing. We'll see the pipeline in action, and we'll see the individual components that we talked about, and how it will translate into a data pipeline, and how it will be orchestrated. So let me just stop sharing this one and share the other. Just to, so, you're able to see the AWS screen, Brian, and others?
Yes, sure.
Yes, yeah, you're able to see, right? Okay. Uh, so as part of the sources that I was talking about, so we'll have two. So this particular engine, right? So first, to familiarize yourself. So this is Athena, Athena service, and this is a query editor for Athena. So now first we will look at the input data schemas, and then I will show you that how that pipeline looks in the Airflow, and how the things will transform from there. So in the Athena, we have like one database called as sales, and in that we have sales information. And if I just query this, so you will see that now this is just a dummy data, very sample data. Now you see that there is one, the sale, there's a unique identifier. This ID is the sales ID. And when the product, like product ID2, some product was purchased on 1st of April, and then it will see, you will see the what was the modified date. But again, you will see that there is an particular some kind of update being done. That's why you might have these cases wherein your source data, if you are using this kind of system like Athena, where you don't have any acid type of guarantees. So this is not traditional RDS. In traditional RDS, you won't have this kind of things because an ID will be a unique column and you might not have duplicates. But we are assuming that this data is actually in a S3 object store, and but in S3 object store, it's not a transactional store. So it might contain duplicates. So it will kind of persist the history, like what happened to how that ID got updated and how it got transformed in time. So it's kind of a time travel. So this right at 4th, like 17th April and around 10:30, this particular row was generated, and there was an update done. Basically, the you might see the quantity changed from 1 to 4, and now this is the recent record. And when you are doing your analysis, it is very important that you pick up the recent record and not the earlier one. So these are the typical cases that you have to handle when you build your data pipelines. And the rest of the information, same, that it is a bunch of information with respect to what are the sales happen and which product ID was being purchased, and what was the quantity in terms of what it was purchased. There's another source we have is the product, and here it will be product data, product information. So we'll just look. So in this table also, that it might contain duplicates, and we need to handle it in a similar way. So here also you'll see the product information, product ID, product name, product price, with self-explanatory, and also the currency in which the price was being shown. So as we'll see that there are two currencies, AED and SAR, and we want to, at the end, we want to convert this to USDs. So that's why we will use the currency converter API. So as you can see for the product ID one, so you can ignore this mismatch. So the product ID one, you will see the name is different. The name is should be same. So it is just since it was fake data, uh, that's why this error happened. But you can assume that this is a product name is jeans. So you will see that uh, the product price earlier was 70, and then the earlier it was 50, and then it was upgraded to 70. It got updated to 70. So this cases will here also will have to do the same thing, that we need to get the recent record for each product ID, so that we are using the latest one and not the earlier one. So this is the second, and the third is the currency converter API. So this is the basically, yeah, this is free API that we are using to just do our currency transformation. So AED and the SAR, we want to convert it to USDs. That is the third source. And this particular sources, now what will happen is, you saw here, we want to generate revenue, that how much like per sales ID, what was the revenue being collected. That is our goal. So here you will see that we have the quantity. So usually how we will calculate revenue is quantity into product price, but the quantity now it lies in the sales table, and the price, it will lie in the product table. So naturally we will know that we'll have to join these two tables, and the common ID will be the product ID. We have a product ID here also, and we have a product ID in sales also. This product ID will join on that, and then we will be able to calculate the revenue, and that information then it will be stored in our data warehouse, Redshift data warehouse. And I showed you the schema, that what the schema looks like and what data will be stored. So as part of looking at this visually, that how does it look into an airflow system? So the screen now you are viewing is, this is the airflow tool, and now you will see that there are certain now this product analysis report, revenue table ETL, these are called as DAGs, directed acyclic graphs, and these two ETLs are already existing, so I've just created and kept as part of, just to show it to you as part of the demo. And now to give you an overview of this tool, so it has bunch of features wherein you will see what were the recent tasks that are in running state, the diagrams. Then you will see bunch of controls uh, here being shown with respect to uh, playing. I mean, there are, so each of these icons, they mean something different. And it has so like let's just dive into one of the decks. You will come to know better. So like this is the tree view, and let's just see the graph view. It's more easier to understand. So as part of this, now the diagram you see, right? So this has two nodes. So it's a graph which has two nodes, and each of this node is responsible for executing some code. Now the first step, right, in your data pipeline is to run a query against Athena and to bring the data into a staging area in S3. So this is what this task will output. So it will run a query in against Athena, and it will bring the data to an S3 location that you have specified. And after that happens, we will get the data from S3, and we will get it to a Redshift table. So this is part of this ETL is doing these things. This product analysis, so it's building this product analysis report. And the first one was the revenue table. So now this has a few more steps. So the first step is, again, we have to do some data processing and bring the data to some staging area. Then we will perform data validations. We will also, after some time, I will also walk you through the code, that how actually the code looks like. We will validate the data. Then we will again copy the data to a Redshift staging table, and finally we will do an upsert and get the data into a final Redshift table. So each of these nodes that you see, right, these are all Python codes, and we called it a uh, Python tasks. So each of these node is responsible for its individual operations, and you will get to see a lot of other functionality here. For example, based on logging, like I just want to view the logs. So if I just click here on this node, so I can see that I can, if I click the view log button, it will give me the log, view log, all the logs. If I clear it, it will start again running the pipeline. So for example, let's just look at the logs itself. So these are the logs that ran. So as part of that step, it ran this particular query against Athena. Then you will see the query states. Then you will see again, okay, we are, look, here we are fetching the sales information. We are getting the product information. Then we are converting some. So these are all logging that I have mentioned in code. So we are like doing currency conversion operations, and then finally we are writing the transform data to some data, like to a object store, that is this path on S3 it will be returned to. And after that, later on you will see the other steps. So I'll just to show you in action, I will just rerun it, and then step by step, let's see what happens. So if I just click here and just hit clear button, it will rerun the same pipeline again. And after that, after we visually see the flow, then I will walk you through the code, that what was the code that powered this particular operations, and how does the code look like. So it will give you some good understanding of the entire process. Uh, so while the time this is running, so you feel like, are you following? I just want to know, are you guys following along, understanding and understanding things? Is it?
Yep.
Great, great. Let's just refresh it. Okay, see it's running here. Let's see in what kind of operation it's doing. So you will see, okay, it has already succeeded, fetch the sales information again. It has all now this particular, you will see that it's getting the product information. So this is the query states, it's the Athena query states. Basically, it's a state machine. First, the query is queued, then it will go to a running state, and then based on the result, it will go into either failed state or succeeded state. Uh, I hope now that it goes into succeeded state. Yeah, so the things are completed. It has converted the operations, and the data is being written to this path. So let's check this path on S3 that we have this particular file existing. So I can go here. So this is the actual bucket wherein the data is stored in temporary data store. And this is the particular path I have mentioned. So you will get to know, oh, this is not this. You will see it is stored in dev public revenue staging, and we have a file called as revenue staging.csv. So it's dev public revenue staging, and it's now you can see this CSV file has already been created. And if you want to check that, so you will have you can see the last modified timestamp. So I am in GST. So here it's 5:54 p.m. So you can see it's been created just now. So now we have this staging file, and the next step in the pipeline was to get this data from staging area on S3 to a particular staging table on Redshift. On and no, also the data validation piece. So okay, the data was also validated. So it will take that this revenue staging, this particular CSV, and it will load into a validation framework, and it will do some checks. So we'll go through that, what all checks I have mentioned for validating the data. So you will see that all data validation tests were succeeded. So what were those data validation tests that will perform? We'll look at it later. And then the third operation was get the data to a staging Redshift table. So here the usual mechanism that happens on S3 is we run a copy command, uh, and that copy command is responsible for getting the data from Redshift from the S3 source to the Redshift table. So here we are loading first data into a staging table. So we make sure that we truncate it. And after that, this particular copy command runs. And it's very efficient, and it's used for bulk loads. So if you're dealing with bulk queries and bulk data, huge data, and if you're on AWS and if you want to copy data to Redshift, so this is the most efficient way to do that. Using copy command, it's AWS recommended. So you have to give the target table name, then from which source, that is what is your path where the data lies, the actual data set lies. So this is the path. Then you have to specify an IAM role. Basically, IAM role in AWS means what kind of permissions does this Redshift has to perform the operation. And these are bunch of optional. These are Redshift copy options. So basically, I am mentioning that my source is CSV. I'm giving that accept all type of characters, accept any date format. Then if truncate columns means if I at the destination, if there is a varchar column, and if I say that varchar column should be of size 50, but in my source here, I got of that particular varchar column to be of like size 80. So then what it will do, if you have mentioned this copy option, so instead of throwing that error, it will truncate that column. So it will only store the first 50 characters. And then what I'm saying, ignore header means usually CSV is the first line is usually the header. I don't want to copy the header as is already created in the Redshift. And that's why I'm saying ignore header. Now this data has gone to a Redshift table. It is revenue underscore staging. And the final step is to perform an upsert operation. So I will also show the data that how does it look like in Redshift 2. The final step was staging to target, from the staging table to target table. And this target table is something which is a production table, and which is available for you for the general, like your within your company or everywhere who want to do the analysis, they will be using this final table. So what I'm doing is I'm making sure this delete operation, what it does is I'm making sure that in the staging table, if there is any information that has got updated for a particular ID which was already existing in the original table, I make sure that I delete that record and I reinsert it with the latest information, and I make sure that it's not duplicated, so the all the IDs are unique. So this is what this query does. But first it runs the delete statement, and then it runs an insert statement, insert into final table from the staging table. That's what this step does. Now let's look at the, so this is the Redshift console, Redshift cluster console query editor, and we'll connect to the database. And the it lies in, and we have a lot of schemas. So the tables that we are dealing with, it's in the this particular schemas. So as you see, the data was loaded into this particular table, and then it was inserted into this final table. So let's just query the final table and see what it consists. Here also let's do order by ID. So as you can see, the data is already existing, and we saw that this is the sales ID. You saw in Athena console that the if I just try to preview this, you had two records for the ID one, and you wanted the latest one with the quantity 4, and you want to ignore this particular one with the quantity 1. So you can verify that in Redshift that it has picked up the latest one, the ID one with the quantity 4, and that's how now here it has done the revenue calculation, and it has done the revenue equivalent revenue calculation having the quantity into product price, and then it's being stored here. So I have not truncated those decimals. Just is because since this is just a demo, not a production system, but usually in production system you might want to truncate it to few decimal places and not having 10 to 12 decimal places. So this is the information. Now you can do bunch of stuff. You can build some visualizations based on, and you can do some more aggregates, right? So you might want to know that what was the revenue generated per product ID. So you can write a query wherein you have a product ID and you can sum the revenue per product ID, and then you might want to visualize that at the end. So this was the first output table to do this revenue calculation. And the second was the, you wanted to generate that particular report, that the product analysis report. So that second one is pretty interesting. So we'll take a look at that pipeline. So once this table is generated, right, now we have this table ran. Now the second table is the product analysis report ETL table. So it has two steps, wherein we run a particular query on Athena, and then it will store to some staging area we will see, and then it will get the table directly to a report schema in Redshift table. So we have a reports schema. So if I go here, there's a report schema, and the final data, the product report data, it will lie in here. And after that, we will also visualize it to see that what kind of answers does this report give us, like what kind of insights does this report give us. So let's rerun this pipeline too. Yeah, so while that's been run, I'll just show you uh, like based on the things we discussed. See, the product analysis report table, it will contain 4 columns. It will have product ID, product name, then was sold at least once, means I just want to know that whether that product in its entire lifetime was it sold at least for once. And the max days bought is the continuous time period. I mean, what was the maximum continuous days on which that product was bought by a customer, or we are not having any customer information yet, but it's just for our analysis basis we have mentioned that what was the maximum number of days that particular product was bought. So we can calculate the to use for calculating the product popularity informations. So you can see this particular task succeeded, and let's see what it did. So you'll see that it ran this big query. So this query is responsible for generating the report. So if I just copy this query itself here, and if I run in on Athena editor itself, it should generate that report. So we'll see the query succeeded. It copied the data to this staging area, and from the staging area, it will go to the final area. So let's just run this query for fun here. So this query, last night, I was writing this query to solve this particular use case. I thought it will be very good to show. So you can see that at the end, we are just generating 4 columns, but you can see the query that's being involved for generating the entire report. So it's, yeah, quite good, and it's quite interesting. Let's run it. Yeah, so you have the information here. So this particular report, right, what you see, now we are utilizing the source tables. I mean, the tables, the sources that we utilized were the sales data and the product data, and based on that we have computed this particular information. And now we have the product ID, and this we have the shirt, and yes, it was sold at least once, and the max number of days it was bought continuously was 4. And then you can see the product ID for that table. It was never bought, it was never sold, so that means there is no max days it was bought. On S3 also, the intermediate store, we are storing the data intermediate into this particular bucket. So we have this temporary data store bucket. So this path also has meaning. So what it means is, so public means it is stored in public schema in Redshift. This reports means is it is stored in reports schema on Redshift. So why we do these things is just data organization. So it's just that how you separate things so that it's not mixed up. And if you want to retrace, right? If you want to, so this is something persistence and it creating a watermark. So in case of any failures, and if you want to debug anything, so I can just directly go here and look at this CSV file and see like what went wrong, and I can do my any kind of debug analysis. So this report, it was generated, and now this particular CSV, let's see if the task succeeded. Yeah, so it succeeded, then it ran that again, that copy command that we saw earlier. So it truncated the actual table, and now it has reinserted the fresh report to that particular product analysis report table. So let's just query that table now. Reports dot. So you'll see that the same report that we saw on Athena, it's existing here. So on this now like just to show like quick visualization. Now this particular Redshift query editor, it gives us the visualize, some can just generate some basic visualization on X and Y columns. So for example, on my X axis, I want to have product ID, and Y max days bought. So, and I will change this to bar graph. So you can see the quick thing that you will know that the product 2 is quite popular, and people are most people are like inclined towards buying that. And what was that product ID 2? You'll come to know that here it's a shirt. There is some maybe particular shirt that people are interested to buy, and that's why it has this kind of ratio. And you will know that the product ID 4, it was never bought. So that's what I was speaking, that if this product was never bought, then might you might take a decision to discontinue it from an inventory because people are not buying. Or you might launch a campaign, some marketing campaign, so that people buy that product, offer some discount to customers. So this gives us bunch of options, and which one is would be the better for the company, you will go ahead with. So just this simple analysis also answers a quite a number of questions, and yeah, quite interesting to see that how the, so what we are doing here is doing data processing, and we have the transform data set, and now we are just having some use cases in mind, and we are trying to and this visualization is just telling us some quick insights, so it will help us to make decisions. So this was the overall pipeline flow, and the next part that's remaining is just the like the code. Like we'll go over the how the code looks like. So the things here, it looks bit simple. Okay, there are only two steps in these ETLs. For example, this particular let's take the revenue ETL, and you will see that okay, just these are just 4 steps. But as I mentioned, that behind every step there is a code running, and you can also see a code. If you want to quickly see, you can also see a code here, but I'll show it in my console. So this is the actual revenue particular revenue ETL. This is the main file, and as I said, all the things are written in Python, and this is how the DAG is being set. So this is the directed acyclic graph. So you have in Airflow, it provides a DAG object. You in the DAG object, you specify a bunch of details, like is the DAG ID. So this DAG ID gets rendered here. You will see the name, revenue table ETL, start dates. Schedule is the cron. So the schedule interval is this cron. You will see that it's schedule interval here. If I have to show you, if you observed it, the second X schedule, it will show you that what time does it run. So this particular ETL is scheduled to run at 2 a.m. every day. So the star means all the days of the week. So this is the, it follows the cron terminology. If you're familiar with cron jobs, you will know that how to write a particular this. What does this notation mean? So the active runs means just I want to have only one instance of the uh, pipeline running at once, and here I haven't mentioned, so, and also the default arguments. I have passing some arguments. So for example, retries, right? We want to do retries. If there is some failure, at least I want to retry twice before reporting the end failure. And in this case, I have integrated particular like Slack notification channel. Right now it's not there, but in case of in production scenarios, you will have to do that integration. And in case of any failures, you will report the failures to that particular channel. So this was the first step, right, in the pipeline. The first step was process data and store to staging S3. If I go back here, so that was the first step, process data and store to staging S3. And this is the code block that runs. So this is a Python operator, and this Python operator is, so one of the argument you have to pass is the what function to run. So I'm running this process data and store to staging S3 function, and I'm passing a bunch of argument that is needed. So you can see the currency converter API URL I am sending here, and with the key itself, to this particular function. And where does this function exist? So it exists into my, uh, you can look at the process. It exists in data pipeline, revenue UTL. In revenue func particular module, I have a process data and store to staging S3. So it's in here, and this is that function that ran for that particular task. So what it is doing is, it's getting running a query against Athena. It is getting a sales data frame. So data frame, I mean, I'm using pandas. So once the data is query is run against Athena, so I'm returning the query results as pandas data frame. So I got a pandas data frame. So for, if you don't know, pandas is a module for doing data analysis. The second is a product data frame. Then I want setting up variables for that, what type of conversion I want to do for the currency. Like I want to convert AED to USD and also SAR to USD. And I also send a request to the particular API, the currency converter API, the URL. This is the URL, and I have passed in the information that I want to convert AED to USD and SAR to USD, and I am passing my API key. Then what it will do is it will do the computation and it will give me that conversion. And lastly, I've joined. So that's the thing I was mentioning, that if I have to, the sales has the quantity information and the product has the price information. So I have to join those particular two tables, and based on that, I would have to calculate the revenue. So this is what this particular step does. So you will see this is a condition, like if the product currency is AED, then what I want to do is I want to have the quantity product price into AED. So the AED USD conversion, what I have done, I want to multiply by that. If, or else the second currency was SAR, then that's why I am doing the equivalent conversion here. So it will multiply the quantity into product price into SAR USD. Uh, and after that, I will get this final data frame, and that final data frame I'm storing to that staging path, and it will store it as a CSV file. So this is the bunch of like the now the second task was data validation. Yeah, this is important that I wanted to show. Validate the data file. So here also I am calling function validate data load. And then what we are doing is, once the data is on S3, before it is loaded to Redshift, we are validating the flow. So if the data validation fails, that means it will send us an alert and the data won't get loaded to Redshift. So it won't, so the Redshift will never be having any corrupted data. So whatever the data is loaded to Redshift, it will all be valid. So it is part of this mechanism that we are doing this data validation. So we are passing the file, that which file we want to validate, where does it exist, and the all the connection parameters. So, and we'll take a look that what this particular function has. So we have a data validation module, and I am using a library called as Great Expectations. So this particular Python library is being used nowadays getting very popular. It is not that you might not have heard. It's just gaining traction, and it has bunch of assertions built in to do the data validation. So for example, one of the data validation is I want expect columns table like columns to match ordered list. So I have this list. So I know that my final data set will have these columns and they should be in this order. So I am doing an assertion based on that. So I'm passing that column list to this particular assertion, and then I will get the result as a failure or something. So if the result is not a success, so I'm just raising an exception and the process will end. The next is the row count. So I want the row count at least be one, so it can't be zero, because in this use case we know that at least you will produce some results. So I'm making sure that the your data file is not empty. Then unique. So we have an ID column. I know that this column should always be unique. It shouldn't contain duplicates in my target data. So it will do a check, and if there is any duplicate, it will just report that particular failure. And I know the bunch of columns are there, like for example, ID column, revenue USD, particular column should not be null. Then and the type of right the set that this revenue USD column is there. In now this column is in the data frame, so it can only be in integer or a float. It cannot be characters. The revenue information can only be in integer information. It can be a float information. Float the data types basically. It cannot contain any other third data type. So it gives me flexibility to specify this, and I can do this kind of operations. And also, but if I have to match the date formats, I want that all my the last modified date column should follow this particular nomenclature, that is year, month, day, hours, minutes, seconds, and milliseconds. This is how I want all my date format, date time should be in. So if any row it is not in this format, it will just throw an error. So this is the data validation module. And if I just want to show the library that I'm talking about is this great expectations. Uh, you will see this, not just cut this. So this is the particular library. So basically what it does is, now when you write your own software, you have a testing mechanism. So for software testing there are a variety of tools, but for doing the data testing itself we have very limited tools, and some of the tools are coming up. So one of the libraries that is getting popularity is this great expectations. So basically what we do is data testing. So and it has a lot of assertions built in. For example, I might be able to show you what are assertions that does it contain. Yeah, so these are the like type of assertion, inbuilt assertions that you can do on your data. So we did some of them, like for example is expect column values to be unique, to not be null, to be of type, to be in type list. So but there are like based on the use cases they have built in a lot of inbuilt assertions, and they're very powerful. So if you were like looking for how do we perform data validation, then here is the answer, and you can also explore this library more. It's an open source project. You can go to its GitHub, and then you can like, and it has a lot of more features actually, and you can explore the what all other features that it does it have. So that was the code for with respect to the revenue. And for the product analysis is the same thing. The main difference here is the actual like the queries, right? So the queries that we ran, so we have a sql queries.py file wherein I have mentioned all the queries that should run. So one of the query I was mentioning that we should pick up the recent sales id for each particular sale, like the sales record that we have a one id incrementally increasing in the sales table, but we want to pick up the recent information. So this is the query that does that. So that for example, first I get the maxed last modified date for that particular id. It's group by id, so I know that which record to pick up. Then again I join, it's a kind of a self join. I again join back to the same table to get all the other parameters, that is the id, date, product id, quantity, and last modified date. So this way I will never pick up any old information. So whatever information I'm picking up, it will be unique, and it will be recent. And the same thing I do for the product, and these are the other particular SQLs. So this is how the data pipeline is being set up, and this is called as DAG. And this is the Airflow has a particular structure. Now to set up the Airflow itself is a big task. For example, now I have like it's all Dockerized, so you will see the Docker file here. That and basically, if you don't know what is Docker is, it is being used for packaging your whole application, and then you can then run that application anywhere on the your maybe in-house servers or on AWS everywhere. So just to give an overview or just initial thing that, so this is the EC2 instance where this Airflow is set up. And if I run this command, you will see the containers that are running. So we have the, so these are the, this is the kind of, Airflow is also a cluster. So we have this many components running. For example, we have a worker to execute the task. We have a web server. So what we saw the UI, right? This UI. So it's rendered by the web server. Then we have the backend. So it uses a backend. So we are using Celery executor, and that Celery executor is utilizing Redis. So whatever the tasks that are being submitted to the Airflow, right? So it goes through a lot of stages. For example, and to see those stages, you can see now when it is running, you will be able to see here, but you can see it's color coded information because it's also state machine. For example, a scheduled task will be shown like this, skipped like this, and the failed in red color, running in green color, success in dark green color. So this is the various state it goes through. So that is the and when the tasks are that are being run, it goes to a Redis queue. So the task they reside in the Redis queue, and from the Redis queue, then it is fetched by the worker for execution. Then the worker executes it. So it's a state machine, and we also have a Postgres DB. So all this information that you see, right, all the task runs and everything, what you see here visually, so it's all metadata. So this metadata is being stored at one place. So this Postgres DB is where all this metadata is stored. So right now, you might have some confusion and things, and that's natural because this Airflow itself can be one session wherein we can go over the cluster details and then how to set it up. Then if you don't know what a Docker is, then how to Dockerize the application, then how to spin it up onto AWS. That is all not, but that is comes at part of data infrastructure. But today pipeline was focused on only the how to set up a data pipeline using the tools. But and all the but that is the like now you might know the data engineer what kind of things he is involved in. So it's not only building the pipelines, but to set up the infrastructure is also equally important. And also with respect to the networking that happens, also the security. So for example, just to give you overview, this AWS console, so it everything is set up in particular VPC. What is VPC? Is the virtual private cloud. Within, so you have all the components residing in one particular virtual private cloud, and a private cloud has a lot of subnets. So if you have done networking, you will note these terms called as subnets, route tables, internet gateways, NAT gateways. So you should be like kind of, if you want to be an expert data engineer, and also as a geospatial data engineer, so these networking concepts are also very important. So you should be like, you should familiarize yourself with this. And so if you don't know, if you're already aware with it, then it's well and good. But if you don't, then you should also take up this task in your bucket list, wherein you can start exploring that how the things are being structured, how the networking works. So all the things that we set up, right, it's in the particular VPC. Now all my components are residing in this particular D means data engineering VPC stack, and this is a VPC ID. It has a bunch of subnets and it has bunch of IP address space, and these are all the like route tables and things are being shown here. So to set up this infrastructure also, right? So I didn't set up like this VPC just by going to the AWS console. So for this, to set this up also, we have a lot of tools now. So it's called as infrastructure as code. So one of the tool is the Terraform we use. This is one tool, Terraform, by HashiCorp, and it is to write to basically write an infrastructure plan and then spin up the infrastructure on your cloud. So it's basically you write a code to spin up all your infrastructure. So in my case, I have used the other version. Uh, it's called as CDK. Uh, it's Cloud Development Kit. So what is the advantage of this is it does the same thing. It is used for to define your cloud application resources, but here it gives me so that I can define those resources using my favorite programming language. For example, I have expertise in Python, so I chose to write the infrastructure in Python. But you can also use TypeScript, you can use Java, you can use .NET for writing those things. So just to give you a very quick example. So for example, this is my VPC infrastack, and just a few lines of code, and that few lines of code has done a lot of things in the background. So if I just open up this file, so you can see there's a class called as VPC stack, and I have mentioned my some bit of configurations that this particular subnet, ingress subnet, will be public. Then application subnet, it will be a private subnet. Then I have mentioned CIDR block. The CIDR means classless inter-domain routing. It is based on what is the range of IP. So what it defines is the range of IP addresses. So I will say that my IP address will start from here, and it has, so this /20 also has a meaning. So it means that how many IP addresses I can consume. And then max AZs means if you know the availability zones on AWS, so it is spanning over two availability zones, and this is where I pass my subnet config. So when this is run, what it does is it will generate a cloud formation template basically in the background, and that cloud formation template, it gets that it's pinned up into our AWS infrastructure. So if I just uh, want to show you, so this is the template that it generates, the Python code that we wrote. So this is the template that it generated in the background, and now this is the cloud formation template, and this template gets provisioned on the AWS. Now if I go here, if you are familiar with the cloud formation, you will know that what I'm talking about. And now that particular template, you will see it will be existing here. So you can see DVPC stack. So this stack has that, and you will also see, we will to see that what all resources it created. So you'll see the how so many, with those only 10 lines of code, I've created so many resources. uh, yeah, so this is the integration of everything, like in the data engineering world. So there is data infrastructure part, and there is also a data pipeline part. But along with the data pipelines, you also should know about the infrastructure, how to set up with the infrastructure. That is also very important from the data engineering perspective. And that happens slowly and steadily. With your experience, you will get come to know. I know some of the things here are a little complex, yes, but with right methodology, and if you are persistent enough, you will be able to gain expertise in it. Yep. So that is was the end of that slide. After that, it was only like I'll open up for Q&A, and if you have some questions, we can go over it. Yeah, Brian.
Yeah, it has been quite an amazing presentation. I don't know if that
Yes.
engineering is now scaring some people. Some people now understand
So it's
what
step by
it
step
is all
process.
about.
Yeah, it is a step
Yeah,
by step. Yeah.
yeah, but yeah, in the same concept that you guys have seen, like for example, now in this case, we're trying to it was a mini demo to help a business to know what is doing well, how in which products is doing well and in which products is not doing well, right? So this is a case applicable to all business basically, and it was a great demo of the infrastructure and stuff, and how to build the pipeline. Yeah, and interestingly, like even for the in the geospatial side of things. We tend to share some things now, like for example, now on the currency conversion for us, maybe at that time we'll be putting to convert the data sets into the same projection coordinate
Mm.
system.
Yeah.
right? Or resampling satellite. If you're using satellite images, the guys in remote sensing, maybe you want them to resample them to be in the same pixel, that is maybe 30 by 30 or whichever size, right? And then after that, you can do zonal statistics and put the final result to be something to be visualized or something else. Oh yeah, and also you can do the data to check the data qualities and stuff. You can always try to. So for example, right now for us, we usually download satellite images from a portal. It depends. So you can always do a check, and you can be notified if maybe the server is down. So for example, if you're getting a data sets from NASA, because I know some people have implemented this kind of things. So they expect to get the data maybe monthly, and if NASA website is down, they get notified by Slack, and then you can notify the NASA and stuff. So it's amazing, interesting, and that's why you're finding that with the massive tons of data, that's why now geospatial data engineering is becoming a trend. But I think they still struggle when companies look, because I think most people are not looking into it that seriously. Most geo people, I think, are focused on analytics.
Yeah.
And so I think, yeah, and the more data sets, as you are in the era of data, and more data is coming, definitely it's great. If someone isn't, you think just special data engineering or data engineering in general, because even again, after learning these skills, you won't limit yourself into geo and being a geodata engineer. You can just be also a general data engineer, right? And that's the beauty of having transferable skills. Because data is data.
Yeah.
We just happen to focus too much on the geo, us geo guys, but yeah, data is data in the end. I don't know. To me, I'm so happy
Yeah.
with it. I don't know if anybody has got questions.
Yeah.
The floor is open.
Yeah. Yeah.
Yeah.
Yeah. If anybody has questions, yeah, we can answer it. Yeah.
Okay, hi guys.
Hi.
Hello. Hi,
So
Calvin.
just going through the demo and basically the topic of today and just sort of seeing basically the entire content of today. I was just looking at some of the things. So I realized like going through the demo, the code out itself is more like, so we, or maybe as an individual, you get to do most of that stuff. Maybe you write a simple Python code and do it on your small CPU. But then at such a stage, let's say, depending on the company size and how much they're willing to spend, especially if they're going to go on cloud platforms,
Mhm.
then that's the point. Now we have to use a different set of softwares. So I don't know. I'm sort of some
So,
questions that sort of been running through my mind. I don't know, because I
yeah.
know at the company, I know we don't do much of. We still do a lot of data, but it's more big in terms of satellite imagery. But then
Mhm.
besides the satellite imagery, then it's not really big data. It's not really like, we don't really do like the cloud processing using now the different platforms in the cloud. We download, do our processing, and that's
Yeah.
it. Write applications, then
Yes.
we
Yes.
website that do that. So the aspect of
Yeah.
costing, because I know Google is
Mhm.
turning out to be really expensive, but then I'm like,
Yeah.
for a small company, or for a small
Mhm.
company, I don't know, like, would it be ideal for somebody to sort of invest
Mhm.
in such a, let's say, a cloud
Mhm.
platform and deploy such applications
Mhm.
and and the Apache Airflows?
Yeah.
Can I
Yeah.
still use my skills as the data engineer, the data processing I do on my small PC, then
Mhm.
apply for such a position that requires, let's say,
Mhm.
cloud
Yeah.
processing, then learn from that, run
Mhm.
the tools that they use on the other end?
Yeah. So to answer your question, like Kelvin, yeah. So even if your company is small, and so your question was very good, how we assess like the cost and everything. So the cloud infrastructure is for everyone, right? So let it be a small company or let it be a company as good as Facebook. So you can utilize tools based on your. So it's not like you only have one tool on AWS which will do data processing. So based on your workloads and based on your use case, there are other tools available. So for example, for today's thing, I just took a example wherein will be an ideal use case wherein we integrate this kind of components. but you can also build your pipelines on AWS using entirely different set of components, which will be and based on the cost. So usually it depends. Right now, you're, for example, you said that you're using a personal machine for data processing, and that's fine. So whatever memory and CPU you're using on your personal machine, you can have that kind of memory considerations on AWS, and you can spin up a small infrastructure, and it will not cost that much. And so, but it will give you advantages. So because maybe, like for example, your personal machine, sometime I mean, like if it crashed or something, or whatever happens, and you're working on some code, it might get lost if you're not using version control or anything. But and also with respect to availability, and if you want to share your maybe your work with other people and things, and within your company itself. So it's good to have one central space, and ideally nowadays it's cloud. And now when I say cloud, so it's not only like this hosted cloud, right? It's not AWS or Google Cloud or anything. Your company can also have your in-house cloud infrastructure. There are also tools for that, like for example Cloudera or anything, and they have their own set of components involved, which can mimic the same pipeline we saw. But the progression nowadays, right, it is to move towards this kind of things because of the advantages it provides. So it in a variety of scenarios with respect to AWS and Google, and specifically with AWS, even if you have a small infrastructure, a company is small, there I don't see any blocker to use the cloud environment. So it's just that you will have to do some cost analysis, and it actually, if you're saying that your data is processed on your personal PC itself, then it won't cost much if you do the same thing on AWS. Yeah.
Okay, thank you.
Any person with a question?
I think someone has raised his hand. Yeah.
Okay, yeah, Davins, yeah, sure. Give it a shot.
Hi, Giant.
Hey, hi. Yes. Hello.
Thanks for the good presentation, the good showcase. Mine is more of a shoot your shot, not a question. It's more of a shoot your shot. So, as the lead data engineer, are you guys
Yeah.
hiring?
What is your question?
Oh, it's not a question. It's more of a shoot your shot.
Are you hiring?
Oh, are we
The question
hiring?
is, are you hiring? Yes.
Oh, are you hiring?
Yeah.
Okay. We will surely hire. Yeah, we will have positions in coming time. Yeah, we definitely, we always looking out for best experts, and we will surely have positions out. And you can also connect with me on LinkedIn, so you will be updated, or also like Brian also can communicate. So, but yeah, for sure we will have in coming 2, 3, 4 months, we will have open positions for hiring data engineers.
Okay. Maybe to just to add on to that question, like the specifics, the strongholds to consider in preparation.
Yes, yes. So, right, for example, now the company, for example, just to give a heads up, so we work a lot in AWS, right? So most of the things are running on AWS. We use all AWS infrastructure components for doing any kind of like application processing, data processing. Everything is running on that cloud. So, and nowadays, like, it's not even like that. I mean, even it's fine if you don't have experience with AWS, it's okay. You can always learn it. But it's just an added advantage if you have experience with cloud environment. Let it be GCP, AWS, or Azure. It can be anything. There is no specific hard line. Okay, he's expert in AWS or something. Then only we'll hire. There are much other skills. For example, we assess a lot in critical thinking. Let it be data structures and algorithms. It's as good as a software engineer interview. Though the position for data engineer, but data engineers now it's just a fancy name in today's world, but they are mm, as good as a software engineer itself. It's just that data engineers they deal more with the data aspect and more with the data infrastructure. But the interview process or your preparation, what will help you is the basic networking concepts, then your data, you should be putting data structure and algorithms, uh, and then any programming skill, right? You might be, it's not like Python, you might be expert in Scala, you might expert in Java, anything, but make sure that you know that particular language very well. Yeah, that will be my, yeah. Yeah, does that answer?
Okay, yeah, thank
Yeah,
you.
yeah.
Perfect. Any more person before we close? Okay, yeah, seems that's it. Yeah, it was super amazing, actually. Super, definitely. I really loved it. Yeah, guys, it's you definitely, if you felt you missed some things here and there, definitely, since if it's your first time, definitely some things might not be clear. But if
Yeah.
you pump in the time and learn, you always grow. That's okay, and that's where we are doing this stuff. Yeah. Uh, yeah, man. Thanks a lot. I really don't have anything to add. I really appreciate for this. And you can, oh, Davin, you've raised your hand again. Yeah, you can talk.
Yeah.
Yes. Okay. So, James,
Yeah.
we've seen like we had the recent NVIDIA GTC. We've seen now most cloud processing moving to TPUs and
Mm-hmm.
GPUs. That
GPU.
having like an expertise in maybe NVIDIA GPUs give you
Mm-hmm.
an edge to cloud computing or anything. And then also the current trend of on edge analytics or devices.
Yes, yes. So yes, that is definitely. So you're saying that will it help in your interview process or anything like that? So is that a question that will it help you?
It's more like because we've seen GCP now investing more in TPUs,
Yes, yes.
like Google
Yeah, yeah.
investing in TPUs, and then now we saw last week's GTC we saw like collaboration. I saw like collaborations with AWS collaborating with
Yes.
NVIDIA, also Azure
Mm-hmm. GPUs,
collaborating
yeah.
on the GPU aspect. So, do you foresee a point where GPU programming would be relevant in data engineering or data orchestration?
So so GPUs and TPUs nowadays. So this kind of this kind of hardware is little expensive to provision, and it's mostly used in machine learning problems, right, nowadays. And when we talk about machine learning problems, then why they are being utilized to run machine learning algorithms? So that training time, to reduce the training time. So on traditional hardware, commodity hardware might be an algorithm running for training for 5 6 hours. It might just run for few minutes on TPUs or GPUs, and you will get your result. So I think now it's being used for machine learning problems. So do we need for data engineering itself? uh, Now it ranges, right, Night, with what volume of data you are using. If you're on petabyte scale like Google, Facebook, Amazon, so those guys, they might be already be using this for their internal data processing, for processing the data on using this kind of hardware. But majority of the companies, they won't have this kind of massive volume. So when you don't have that volume, then it is not that a need. So it just based on use case and with what quantity of data you are dealing with, that will define that whether to use TPUs or GPUs or now. So, and if your question is it already being used? I think it must be already being utilized by big players in the market, so that they speed up their data processing.
Okay. Thank you.
Yeah, yeah.
Okay, great. Yeah, it has been a great discussion. Thanks, Jan. If someone has got any question, yeah, Jan is a great fellow. You can easily connect with him on LinkedIn. Yeah, for the geoinformatics guys, or geo, or if you do anything in geo and related to combine geo and tech, usually have a kind of a WhatsApp group, usually discuss if you get challenges and stuff, when you get a problem, just shoot it there, someone else will answer. I think it's almost full. I think we're at 230 something, 5 or 7, I can't remember. But I've added the chat, I've added the link for the WhatsApp in the chat. So feel free to join or add a friend. It's fine. That's it. Then already on a weekday for us. From tomorrow is a weekday. So I wish everyone the best new week. And yeah, let's keep sharing content. And if you feel there's a topic, especially the audience too, if you feel there's a topic you really want to have a talk on, definitely just holler. Or if you feel we need to get an expert to discuss something, let us know. Okay, that's it. Then bye, everyone.
Yeah, bye. Thanks, Brian, for inviting.
Bye.
Good session. Bye.